Hello everyone, my name is Rajesh Arsid. I'm Principal Engineer at Synopsys. My presentation is about scaling AI infrastructure with PCIe7 next-gen high-bandwidth interconnect for AI and machine learning workloads. Here PCIe stands for Peripheral Component Interconnect. It is a standard protocol used in the computer for high-speed interface connections to GPUs, network cards, and SSDs. AI infrastructure bottleneck. As AI model grows exponentially large, current interconnect technology has become critical performance bottleneck in distributing training environments. Traditional PCIe generations like PCIe 4, PCIe 5, and PCIe 6 struggle to keep the pace with GPU computational advances, creating communication overhead that limits scalability and increase training times. PCIe 7 revolutionary bandwidth leap. Why is PCIe 7 specification more superior? Because of its unprecedented throughput, substantially increased performance over previous generation. So what does it mean is if I consider the previous generation PCIe 6, which has a data transfer rate of 64 gigatransfer per second, while compared to the latest PCIe 7, which has 128 gigatransfer per second, almost double the data transfer rate. The second point is enhanced bandwidth efficiency, which significantly improves over the previous generation. What does that mean is if I consider PCIe 6 under X16 link configuration has a bandwidth of 256 gigabytes per second compared to the latest PCIe 7 under similar X16 link configuration would show 512 gigabytes per second, almost double the bandwidth. Also, there is a latency reduction, significant reduction for distributed workloads. So this performance gains directly translates to faster training models, reduced communication overhead, and improves resource utilizations in GPU clustering. So here are the key technical advantages of PCIe 7. It has enhanced error correction, advanced ECC mechanisms, reduced system interrupts, and improves reliability. It has a power efficiency. Optimal power management delivers better performance per watt. Also, it has a backward compatibility. What does it mean is a component designed for PCIe 7 can be used for PCIe 6 and 5. So this is an added advantage of using PCIe 7. Architectural integration. So the next gen PCIe pairs synergistically with CXL and high-speed Ethernet to create a unified high-bandwidth fabric architecture for long-distance high-speed communications. So this combination unlocks next level of memory bandwidth and computational density, enabling more efficient resource pooling and dynamic allocations. So there are three stages of implementation. So in the early stage, we would use like for testing and validating in hyperscale environments. It takes some time for testing and validation. The second stage would be an intermediate stage where the production deployment in tier one data centers and HPC facility. And the third phase is a widespread integration. So in this stage, we use a widespread adoption across enterprise AI infrastructure ready to use PCIe 7 specifications. Target applications. So PCIe 7 can be used and it is ready for hyperscale data centers, hyper performance computing and quantum computing. So what does it mean is hyperscale data centers which has a massive GPU clustering for foundational model training and interface at unprecedented scales, whereas high performance computing scientific simulations and modeling requiring extremely computational density. And the last one, quantum computing, hybrid classical quantum system demanding ultra low latency interconnects. So the PCIe 7 specification is kind of offloads the AI capability here. The future ready foundation. PCIe 7 represents more than incremental improvement. It's a foundational technology enabling the long term future of AI infrastructure scaling. What are the key takeaways? Organization planning AI infrastructure investment should prioritize PCIe 7 compatibility to ensure scalable, energy efficient, and future ready deployment. Thank you so much for taking time and listening to my presentation. Thank you so much.